Hi friends, welcome to this video. Today we are going to explore something super cool from the world of machine learning. It's called a K-means clustering. Imagine if you could group similar things like people, product or pattern without even knowing what they are. Sound magical, right? It's exactly what K-means does. Well, start with a simple explanation, step by step working, a real code example in a Python, and finally some advantages and limitations. So let's get started. So firstly we will see what is a K-means clustering. K-means is an unsupervised machine learning algorithm. This means it works without labeled data. It the main job is to partition a data into k different cluster where k is a number you choose. Each cluster group together data point that are similar to each other. Next one is the purpose of k-means clustering. The main goal of a k-means to find a pattern in your data without grouping. By grouping similar data points, k-means help us to understand underlying the structure of a data set. This is useful in many real life solutions where don't know categories beforehand. The application for K-means clustering. First one is a customer segmentation, market analysis, image comprehension, and pattern recognition. In short, K-means help us make sense of messy data by organizing it into meaningful clusters. Here, a short and simple version of K-means work. Firstly, we will choose a K. It decide how many cluster you want. Second one is a analyze the centroid. Randomly place K point as a starting centroid. Third one is a assign point. Each data point join the nearest centroid. Then recalculate the centroid. Move each centroid to average of its clusters. Then repeat keep keep doing step third and fourth until centroid stop changing. This is some advantages and limitations of k-means clustering. First one is a simple and fast computation. Next one is a efficient for large data set. Result are easy to interrupt. Limitations of k-means clustering is require k to be chosen in advance, sensitive to outlier and noise, best for spherical cluster of similar size. So we will see one example of k-means clustering algorithm by using Python. First, we import the necessary Python libraries. We are using NumPy with the numbers, Matplotlib for plotting the data, K-means from sklearn for clustering, and Matplotlib to generate a sample data. Let's move on to generating the data. Now we create a synthetic data, just some random point that are grouped around different center. This helps us simulate the real world data where we don't know which data point belongs to which group. Here we generating a 300 data points around with 4 center, a little bit of spread. Let's plot this data and see what it's look like. This look like this. These are just scattered point without any label or cluster. As you can see, there is no ambiguous grouping yet. It's just data, but now we will apply the K-means algorithm to find natural clusters. Next, we create the K-means model and tell it 4 cluster since we generated a 4 centers or centroids. What happening here? This model learning the best way to divide the data into 4 groups by finding pattern. It start with a random point as a cluster or centroid. and keep adjusting them until the point is in best cluster. Now let visualize the result. This plot will color each data point is based on its cluster. Looking great. Each color represent one cluster but yet also mark with the cluster point. So here is code to mark the centroid and visualize this. Here red X represent the centroid. Remember, you have to choose how many cluster you want to beforehand, and the result depend on your data and the number of cluster you pick. If you would like to explore more, try to changing the number of cluster from 4 to 3 or 5 and see how the grouping changes. So this is a final result of a k-means clustering algorithm. Here we firstly cluster the 300 data points and then give us one centroid and mark with a red X, and cluster is marked with different colors. So thank you for watching.